Hello students, in this online video I will discuss how to find out the state of polarization of the given light. So we have to identify the state of polarization. For example, X component and Y component of a light is given, and for this example we have to find out the state of polarization. We have to find out that either this is plane polarized, this is circularly polarized light, or it is elliptically polarized light. And if it is elliptically and circularly polarized light, then we have to find out either this is right circularly polarized light or left circularly polarized light, or right elliptical or left elliptically polarized light. So we will start with this example. So here we can observe Ex and Ey component of the electric field, and both has cos term. So here both has cos term, their amplitudes are not equal, and the argument term, by observing the argument term, we can find out that here argument term is omega t plus kz, and here omega t plus kz plus pi. So their argument term has a difference of pi. So in between Ex and Ey component of this light, phase difference delta is equal to pi. So here in Ex and Ey component of the given example, phase difference delta between the X and Y component is equal to pi. And if phase difference is 0, pi, 2 pi, 3 pi, 4 pi like this, then the given light will be plane polarized light. So this delta equal to pi states that the given light is plane polarized light. So first we will check what is the phase difference between these two terms, Ex component and Ey component, and if this phase difference is equal to 0, pi, 2 pi, 3 pi, 4 pi, a multiple of pi, then we can directly state that this is a plane polarized light. So this is the first example. Now come to the second one, second example. Suppose this is, we have this example. Suppose Ex is given by E naught, this is given E naught sine omega t minus kz, and Ey component is E naught sine omega t, this is cos omega t minus kz. So now these are the X and Y component of the given light. This is the second example. Now how we will find out the state of polarization in this case? How we will find out the state of polarization? So one thing you can observe that here argument term is same. With here we have omega t minus kz, here omega t minus kz is here. So because the sign of omega t and kz are opposite, here omega t has positive sign and this kz has minus sign. So the propagation direction is, so here propagation direction is in plus z cap direction. So basically this light is propagating in plus z cap direction. Another important observation is this is E naught, here this is E naught. So amplitude of X and Y components are equal. So E naught X, E naught Y is equal to E naught. So their amplitudes are equal. This is the second observation. And third observation is here we have sine term and here we have cos term. Here we have sine term and here we have cos term. And you are aware that in between sine and cos term there is always a phase difference of pi. So one term is given in terms of sine, another term is given in terms of cos. So phase difference is equal to pi by 2. Now observe at all these things. The wave is propagating in z direction, phase difference is pi by 2, and the amplitude of X and Y component is equal. So automatically the given light is circularly polarized light. So the given light is circularly polarized light. So from here we can find out that the given light is circularly polarized light. Now important question is we have to find out. Next question is we have to find out that either this CPL is RCPL means right circularly polarized light, or this is LCPL left circularly polarized light. So to find out this, we will write Ex and Ey component at Z is equal to 0. So at Z equal to 0, so first what we will do, we will write Ex and Ey component at Z equal to 0. So at Z equal to 0, this is Ex equal to E naught sin omega t and Ey is equal to E naught cos omega t. So first question arises why we are substituting Z equal to 0, because we are trying to find out, we are substituting here Z equal to 0 because we are trying to find out the state of polarization at Z equal to 0. It will be easy for us because whatever be the polarization will be at Z equal to 0, the same polarization will be equal to Z equal to 1 or Z equal to 2 or other values of Z. So basically we are using the fact that the polarization of this light is not changing as it is moving along the Z axis. So we are using this fact and we are calculating the polarization at Z equal to 0. So here Ex is equal to E naught sin omega t, Ey equal to E naught cos omega t. Now we will draw two perpendicular axes. On the x-axis we will plot Ex and on the y-axis we will plot Ey. So here we are going to draw Ex and Ey component of the given light. First I will find out Ex and Ey at t equal to 0. So first we are calculating Ex and Ey component at t equal to 0. So at t equal to 0, this will become E naught sin omega t. So this will be sin 0. So Ex will become 0. So it will become 0. And what will be the value of Ey at t equal to 0? So this will become cos 0. Cos 0 will be 1 and this will become, Ey will become E naught. So value of Ex and Ey is 0 and E naught respectively at t equal to 0. Now we substitute or we increase the value of this omega t to pi by 2. Now I substitute omega t equal to pi by. So we are increasing the time and this time becomes omega t equal to pi by 2. When we substitute omega t equal to pi by 2, then this will become E naught and this Ey, it will become 0 because cos omega t cos pi by 2 will be 0. So now first we will draw the electric vector on this Ex Ey plane at t equal to 0. So at t equal to 0, Ex component is 0 and this Ey component is E naught. Suppose at this point we have E naught. So this is E naught here, this is E naught here. So this is the position of electric vector at t equal to 0. So this is the position, this is the representation of electric vector. So electric vector can be represented by this at t equal to 0. Now time is increasing and we are trying to find out the position of this electric vector at omega t equal to pi by 2. So at omega t equal to pi by 2, this Ex becomes E naught. So Ex become E naught. Suppose E naught is here, here we have suppose E naught and Ey is 0. So electric vector will be here at this point. So this is the initial position at t equal to 0 and this is the position at omega t. This is the position of electric vector at omega t equal to pi by 2. So this electric vector is moving like this. It is moving in this direction. So this electric vector is rotating like this. This is rotating like this. So basically the given light is right circularly polarized light. So from this drawing we can find out that electric vector is rotating in the clockwise direction. So this is RCPL, right circularly polarized light. So the given light is right circularly polarized light. But here you have to remember one thing, that this is the observer point of view. Whatever we are observing on EX and EY plane, whenever we are plotting EX and EY component on EX-EY plot, whatever we are observing, that is the observation of the observer who is standing at large distance on the X. So what I am saying, suppose this is the Z direction, here, and this is the source here, and observer is standing here at this point. So light is propagating towards this observer. This is observer, this is source here. So this is source here, and light is moving towards the observer. So whatever observer is observing, that plot will be here. Whatever we are observing on EX-EY plot, that is observed by this observer who is standing on the positive x-axis, and light is propagating towards this observer. So this observer observes that the given light is circularly polarized light. So from the observer point of view, I can say this is right circularly polarized light. So this is observer point of view. Now there can be another view, and this view can be for an observer. If suppose I am standing here at the position of the source, and from this position I am observing the polarization of light when light is moving away from me. So I will observe the opposite polarization as observed by the observer. So if the observer here is observing that the light that is coming towards this observer, that is right circularly polarized light, then from source point of view, this light will be left circularly polarized light. So for both the observer point of view, you will find out opposite results. But every time we will consider whatever polarization is observed by the observer who is standing at a large distance on the positive z-axis. So in answers, we will take corresponding to this option or corresponding to observer point of view. So here we have two methods to observe the polarization of the given light. One is observer point of view. Observer point of view is the observation that will observed by us on this EX-EY plane. So whatever we are observing on EX-EY plane, that is the observation made by the observer standing at positive z direction on the positive z-axis at a large distance, and light is moving towards the observer here. So here this electric vector is rotating clockwise in the clockwise direction. So this is right circularly polarized light. But a person who is standing at the position of the source, he will observe the opposite polarization, and he will observe the left circularly polarized light. So you can understand this in such a way. Suppose you people are the observer and I am standing on the source point of view. Now for me, this is the clockwise. This marker is rotating in clockwise direction, and for you people this is rotating in anti-clockwise direction. So whatever I am observing clockwise direction, clockwise rotation of this, and you are observing anti-clockwise. So basically whatever you are observing, I am observing opposite to that. So whatever is the result corresponding to observer point of view, in case of source point of view, result will be opposite. So this was the second example. Now come to the third example of this. So in third example, what I do, in third example, what I am doing, I will make this minus sign as plus. What I am doing, I am converting this minus sign into plus sign. Now you can find out what will happen. Now we can find out what will happen to the state of polarization. So here what we are observing, first we are observing that propagation is in negative z cap direction. Here light is propagating in minus z cap direction. Second, we are observing that the amplitude E naught x is equal to E naught y, and this is equal to E naught. So both the amplitude of Ex and Ey are equal, and the phase difference between sine and cos term is pi by 2. So this delta is pi by 2. So now this light will be circularly polarized light. So phase difference is pi by 2, amplitudes are equal, so automatically this will be a circularly polarized light. Now I have to find out either this is left circularly polarized light or this is right circularly polarized light. So for this I will substitute z equal to 0 here. So this will become Ex equal to E naught sin omega t. Ey is equal to E naught sin omega. This is cos omega t here. This is cos omega t. These are the same terms. So now draw the Ex Ey plane. So I am drawing two perpendicular axes. One is Ex, this is Ex axis, this is Ey axis. Now we will draw the electric vector at two different positions or at two different times. So first I am considering the time omega t equal to 0. So first I am assuming that time t or omega t is equal to 0. So when omega t is 0, then the first term will be 0, this will be 0, and this cos omega t will be 1 and Ey will be equal to E naught. So these are the coordinates of the electric vector at omega t equal to 0 time, and at omega t equal to pi by 2, what will happen? This will become E naught and this will become 0. So now at time t equal to 0, Ex is 0 and this is suppose E naught. Here this is E naught. So this will be the position of electric vector. This is the position of electric vector at t omega t equal to 0. So this is the electric vector corresponding to omega t equal to 0. Now after some time when omega t becomes pi by 2, then Ex vector becomes E naught. So this becomes E naught. This becomes E naught and Ey becomes 0. So the new position of the electric vector is this one. So as the time is increasing, this vector is rotating like this. So this vector is rotating like this. This is the clockwise rotation. So this is clockwise rotation. So here this is clockwise rotation. But here this is clockwise rotation, but you should always remember that this will not be right circularly polarized light. What I am saying, focus on that. This vector is rotating in the clockwise direction, but I am saying that the light will not be right circularly polarized light. So I am saying that this will not be right circularly polarized light. Why this will not be right circularly polarized light? Rather than this will be left circularly polarized light. So why I am saying this will be opposite what we are observing on Ex Ey plane. The reason for this is very simple. You can easily understand. So first draw the z axis here. This is z axis and observer is here standing here on this axis at large distance, positive z distance, and this is the source. Here this is observer, and here this is the source. And now light is propagating in minus z direction. So light is propagating in the negative z direction. So what is happening here? Here light is moving away from the observer. In earlier case, what was happening? Light was propagating towards the observer. When light was propagating towards the observer, so whatever you was observing on EX, EY plane, whatever you was observing on EX, EY plane, that was simply providing me the state of polarization. But now here situation is different. This light is propagating in negative z direction. So this observer is observing this light. This observer is observing this light from the back side. So he is observing the opposite polarization. So because light is moving away from the observer, so light is moving in this direction and observer is observing this light from the back side. So automatically whatever this observer is observing here, that is opposite to the observer point of view. So here in this case, when light is propagating in negative z direction, whatever here we are observing, here we are if we are observing clockwise direction, then this will be left circularly polarized light. In another case, if suppose electric vector was rotating anti-clockwise, in that case it will become right circularly polarized light. So whatever we are observing here, in the case when light is moving or propagating in minus z direction, opposite polarization will be there, opposite to what we are observing on EX, EY plane. That will be the polarization. So in this case, this will be left circularly polarized light. So in this case, this will be left circularly polarized light. Now come to the another example. But here, before moving to the next example, you can write one very important thing. You can note down one very important thing, that whenever you have to write the left or right circularly polarized light, at many times you will require that you have to write out the electric vectors components EX and EY corresponding to right circularly polarized light. If you want to write electric components for right circularly polarized light, then you can write EX equal to E naught sine omega t. This will be sine omega t, and EY component will be E naught cos omega t. You can take this example for right circularly polarized light. Similarly, for left circularly polarized light, you can take the example EX equal to E naught cos omega t, and EY component will be E naught sine omega t. And here, always remember, I am choosing that for right circularly polarized, these are the electric component, and for left circularly polarized, EX and EY are the electric components. But these two are the correct examples only when light is propagating in positive z cap direction. So these, you have to remember these two examples for RCPL and LCPL when the light is propagating in plus z direction. If suppose light is propagating in minus z direction, then they will be interchanged. So you have to remember, you can use these examples. Now come to the next example here. Now come to the next example. Next example is EX is E naught sine kz minus omega t plus pi by 3, and second is EY equal to E naught sine kz minus omega t minus pi by 6. Now we have to find out the state of polarization for this. What is the state of polarization in this case? So first, we are observing that the sign of omega t and kz, we have two terms, one is omega t, another is kz, and their signs are opposite. So propagation direction is plus z cap direction. So light is propagating in plus z cap direction. Next, their amplitudes are equal. So E naught x equal to E naught y is equal to E naught. So the amplitude of Ex and Ey components are equal. And third is phase difference. Both are sign term. So we can find out the difference between these two argument terms, and this will become pi by 3 minus pi by 6. So this will become pi by 2. So here what is happening? Phase difference between Ex and Ey component is pi by 2, and their amplitudes E naught x and E naught y are equal to E naught, and wave is propagating in plus z direction. So the state of polarization will be circularly polarized light. So this is an example of circularly polarized light. But now we have to find out either this circularly polarized light is left circular or it is right circular polarized light. So again we will place z equal to 0. So what I am doing, I am substituting z equal to 0, and this Ex becomes E naught sine minus omega t plus pi by 3, and Ey becomes E naught sine minus omega t minus pi by 6. So we are substituting this value, or we have substituted z equal to 0 here in this case. So now first we will try to find out the state of polarization, left or right circular polarization of this circularly or CPL with the help of this plot in between Ex and Ey component of the electric field. So on this axis we have Ex, on this axis we have Ey, and we will plot Ex and Ey at two different times. So first what I am doing, I am choosing t equal to 0. First I am choosing omega t equal to 0 time. This is a normalized time, omega t is a normalized time, so omega t equal to 0. So when omega t is 0, this is E naught sine pi by 3 or sine 60. So this is under root 3 by 2 E naught. It will be under root 3 by 2 E naught. And this Ey component, so this will be Ex component and Ey component. What will be the Ey component? This will be 0 here, and this will be sine minus pi by 6. So minus sign will be out, minus sign will be here, and this is sine 30. Sine 30 will be 1 by 2 E naught. Sine 30 will be minus 1 by 2 E naught. So these are the values of Ex and Ey. Ex and Ey at omega t is 0. So basically here I am assuming this is under root 3 by 2. This is under root 3 by 2 E naught. So, and in the downward direction this is minus 1 by 2 E. So suppose here this is minus E naught by 2. So this electric vector will be here. The position of electric vector will be here at time t equal to 0. So this is the position of the electric vector at omega t equal to 0. Now I substitute omega t equal to pi by 6. You can substitute any value, but here I am assuming that this is omega t equal to pi by 6. So when I will substitute here minus pi by 6, it becomes here. So this will become E naught sine pi by 6. So it will become E naught by 2. So at omega t equal to pi by 6, our Ex will become E naught by 2. And this will become minus pi by 6 minus pi by 6. So this will become minus pi by 3. So this will be minus here. Pi by 3 is 60 degree. So this will be under root 3 by 2 E naught. Suppose under root 3 by naught is here. This is minus root 3 by 2 E naught. And this is suppose E naught by 2. So here this will be the new position of electric vector. So this is the new position of electric vector. So electric vector is rotating in the clockwise direction, and at the same time light is propagating in z direction. So this will be right circularly polarized light, and this is right circularly polarized light from observer point of view. Observer point of view. So what I am saying, whatever we are observing, so I am again repeating that whatever you are observing on Ex Ey plane, that is the observed polarization of the light coming towards that person. Whenever light is propagating towards the observer, and whatever he is observing, that you will observe on this Ex Ey plot. And when light will move away from the observer, suppose light is propagating in minus z direction, so whatever you will observe in this plot, opposite to that will be the polarizing state corresponding to observer point of view. So this is another example. Now come to the last example. Last example is, suppose Ex is equal to E naught sine kz minus omega t plus pi by 4. This is the Ex component, and Ey component is, this is 1 by root 2 E naught sine kz minus omega t. Now we have to find out the state of polarization for these given components Ex and Ey. So again, what is the direction of propagation here? This omega t and kz, they have opposite sign. So propagation direction is plus z cap direction. Next, amplitudes E naught x is not equal to E naught y. And what is the phase difference between Ex and Ey component? Both are sine terms here. So difference between these two terms will be pi by 4. So this is pi by 4. So phase difference is pi by 4. When phase difference is pi by 4, so automatically the given light will be elliptically polarized light. So this will be elliptically polarized light. This is elliptically polarized light. Now we have to find out the exact state, either this is left elliptical or this is right elliptical. So for this, again I will substitute z equal to 0. So again I am substituting z equal to 0. So this is Ex equal to E naught sine minus omega t plus pi by 4, and Ey component is E naught sine minus omega t. So first I am substituting omega t is equal to 0. So what will be the value of Ex? Value of Ex will be, here we will substitute 0, and this will be sine pi by 4, sine 45. So Ex will be E naught upon root 2. This will be E naught upon root 2, and Ey, this will be 0. Now I take omega t equal to pi by 4. Now I choose omega t equal to pi by 4. So this term will become 0 and this will become 0. And here this will become minus. So minus will be here and this will become E naught by root 2 here. So these are the positions of electric vector at two different normalized times, omega t equal to 0 and omega t equal to pi by 4. Now plot the electric vector on Ex, Ey plane. So we are drawing two perpendicular axes. This is Ex and this is Ey. So at time t equal to 0, this is Ey is 0 and Ex is, so this is, suppose this position of this point is E naught by root 2. So this is the position of electric vector at time t equal to 0. And at time omega t equal to pi by 4, it becomes, Ex becomes 0 and this becomes minus here. Suppose this point is E naught by root 2 here, E naught by root 2 with minus sign. So this is the new position at time. So this is the position at omega t equal to 0 and this is the position at omega t equal to pi by 4. So this electric vector is rotating clockwise direction. So this will be right elliptical polarized light. Why this will be right? This is rotating, this electric vector is rotating in the clockwise direction and light is propagating in plus z direction. So this will be right elliptically polarized light. From the, this is observer point of view, observer point of view. So in this way we can find out the electric polarizations. Whatever is the polarization of the given Ex and Ey component, we can find out the state of polarization, or we can identify the state of polarization if Ex and Ey components of the light are given. So you will follow this procedure, and I have solved sufficient number of examples here so that you will be able to solve all these questions. But first you have to remember this point. If light is propagating in plus z direction, then whatever you are observing on this Ex, Ey plot, the same thing will be observed by the observer who is standing at positive z axis at large distance and light is propagating towards him. But when the propagation direction is minus z cap direction, then whatever you will observe on this Ex, Ey plot, opposite to that will be the observer point of view. So you remember this point and then you can easily solve all these questions. First, you should also observe that what is the phase difference between them. If phase difference comes out to be 0, pi, 2, pi, 3, pi, then there is no need for further investigation, and in that case light will be simple plane polarized light. But in case of CPL, circularly polarized light, and elliptically polarized light, then in that case we should find out either this is right elliptical, left elliptical, or right circular or left circular. Thank you very much.